Hello and welcome. We're going to work with exponential equations as well as equations with exponents, more specifically rational exponents. So let's start with the equations that have exponents in them and how we can go about solving these particular exponents. So let's jump straight into an example that will help us think about how we solve these particular expressions. So if we're given an expression x to the power of 2 over 3 is equal to a number, let's say 1, right? What we would like to now do is say, well, we need to get x completely by itself to the power of 1 with a coefficient of 1. So we've already got the coefficient of 1, but the power in this case isn't 1. So what we can do is we can raise that power to another power to make it 1. Now, if we think back to some of our exponential laws, what we can see is there was a law that said that x to the power of a raised to the power of b means that I have to multiply my exponents together, which means I'll have x to the power of a times b. Now, what makes this particularly useful is that if I look back at my original question now and I come back to my question, what we can see is there a power that I can multiply my power with to make it 1? And the nice thing about fractions is that you can always multiply a fraction by its reciprocal to get 1. So what we can do there is we can say, fantastic, let's take our x to the power of 2 over 3 and raise that to the power of 3 over 2 and see what we get. Now, what we do on the left-hand side, we must do on the right-hand side, which will give us 1 to the power of 3 over 2. There's something I want us to note here in particular. And when we think back to our exponent and surd laws, whenever I raise something to the power of a half, right, anything over 2. So if I've got x to the power of n over 2, what that really means is that I have got the square root of x to the power of n. And whenever we square something, right, or we root it to an even power, so in this case it's going to be squared, it could be a 4 or a 6 or anything else, that means that I'm actually now needing to think about two solutions to this particular problem. So whenever you are raising a power with an odd number at the top and an even number at the bottom, you need to remember that you will end up with two solutions, which is why in this case we've got to then put a plus or minus before we do that. Okay, very important thing to keep in mind, but now we can finish up our solution. So in this case here, the 2 over 3 and that 3 over 2 will cancel to become 1, so we end up simply with an x on the left hand side, and then on the other side there we do keep our plus or minus. 1 to the power of 3 over 2 remains just 1, 1 to any power remains 1 in that particular case. So that's our solution in that case. So very important to note, whenever you're raising anything to the power of an odd number above divided by an even number, you have to do the plus or minus. If the number in your denominator, so let's say for example, if this number here were an odd number, we wouldn't have to worry because that becomes an odd root, and an odd root doesn't really give us multiple solutions. It'll just be one particular solution. Okay, that's an example of an equation with an exponent that is a rational number, which means it's going to be a fraction that we can solve. Okay, now let's look at another example where in this particular case we're dealing with exponential equations, which means equations that have variables in the exponent. Okay, let us look at a very simple example now. Let's look at that, call that example 2. Now, our next example will simply be 27 to the power of x is equal to 1 over 9. Now, exponential equations, we know we'll have an exponential equation, like I mentioned, when we've got an exponent that is the variable, right? So now in this case, what we need to do is that we want to get to the end game of equating our bases so that we can drop our bases. Because, again, when you think back to your exponential laws, if we've got x to the power of a being equal to x to the power of b, what that really means for us is that a must be equal to b. All right, because the bases are the same, and the numbers are the same, the exponents must also be the same. So we want to come back and do the exact same thing on the left-hand side there and make sure that we can equate our bases somehow. So let's think 27, how can we rewrite the number 27? The number 27 is going to be of base 3, but to what power? So we think 3 times 3 is 9, 9 times 3 is 27, so it's 3 to the power of 3. So we can rewrite this as 3 to the power of 3, and remember the x to the power of x. Then on our left-hand side there, we've got 1 over 9, which becomes 9 to the power of negative 1. But actually, we can write 9 as well as base 3. So we're going to end up there with 1 over 3 squared. Now what I'm going to do there is I'm going to just go straight into putting that as a numerator. And we can basically rewrite that entire thing there as 3 to the power of negative 2. So we're nearly there. We just need to fix our left-hand side of that equation. And what we can do there is, again, we've got 3 raised to the power of x over there, which means we have to multiply our exponents, which means we end up with 3 to the power of 3x being equal to 3 to the power of negative 2. Now that we can see that our bases have now become the same, we've got a base 3 there and a base 3 with nothing else in that single term, we can drop our bases and then equate our exponents. So therefore, 3x is equal to negative 2, and now we can then find the answer of our expression there, which means x is equal to negative 2 divided by 3. Now that's our final answer. So that's a very simple example of how we can do an exponential equation. Let's look at another example just now. Okay, so example 3 will be as follows. It'll be 125 to the power of x times 25 to the power of x minus 2 is equal to 1. Okay, now again, here we got to take our expressions and try and find a base that'll work. So I'm seeing 125, I'm seeing 25, I'm seeing 1. So on the left-hand side, I know I can definitely use 5 as a base, right? So 125 is 5 to the power of something. We can think 5 times 5 is 25. 25 times 5 is 125. When you're not sure, what you can always do is we can do what we call prime factorization. So let's do that here on our left-hand side. So what we do with prime factorization is you start with your base number. So you say, well, I've got 125. Now it's called prime factorization because you have to use prime numbers when you're dividing. So 25, the smallest prime number I can use here has to become then 5. And then 25 divided by 5, 125 divided by 5 becomes 25. I divide that by 5 again. That becomes 5. I can divide that by 5 again, and that becomes 1. So then I can see that 5 times 5 times 5 gives me 125. So therefore, you can say 125 is equal to 5 to the power of 3. So if you're not sure, just by looking at the number, what you can do is you can do what we call prime factorization, where you divide the number by the smallest prime factor you can think of in that particular case. So let's come back to our problem on the left-hand side there, and we can then try and rewrite this number. So 125 is 5 cubed, so we got 5 to the power of 3 there, and then there's our x, times, we know 25 is 5 squared, so that's going to be 5 squared to the power of x minus 2 there, and that's equal to 1. But remember, we're dealing with bases of 5 there. How can we rewrite 1 to a base 5? Keep in mind, another one of our exponent laws that I can do here on the side is that any number, in this case I'll say x to the power of 0 equals 1. So that means if I want to put the 1 there as a base 5, I just need to give it the exponent 0. Nice and easy and very convenient for us. So I can then say 5 to the power of 0 would have been 1. Now I've got everything down to the base 5. Let's simplify our expression just a little bit, and then we can work it out eventually. So what we see there is that this expression here is not in its simplest form. Let's try simplify that and everything else. So 5 to the 3 to the x is 5 to the power of 3x times. So we got 5 squared to the power of x minus 2. I need to multiply those together. So we end up with 5 to the power of 2x minus 4. And on the other end, I still end up with my 5 to the power of 0. Now, These are just multiplication signs, just to make them a bit bolder so we can see them. Now on the left hand side of my equation, I've got two expressions where my bases are multiplied together, which means I need to then end up adding my exponents. And we can remember there was, well not was, but there is an exponential law that says x to the power of a times x to the power of b is equal to x to the power of a plus b. So let's use that law right now in this expression and say 5 to the power of 3x times 5 to the power of 2x minus 4. That's going to then give us 5 to the power of 3x plus 2x minus 4 is equal to 5 to the power of 0, which means, again, like we did before, I can now equate my exponents and drop the bases. Let's just get a bit more space here. And then we end up with 3x plus 2x minus 4 is equal to 0. Let's simplify that expression. We know that 3x plus 2x is 5x minus 4 is equal to 0. We can take our 4 to the other side and have 5x is equal to 4 divided by 5, and we get x is equal to 5 divided by 4. So that's how we can solve that particular exponential equation. Let's look at one that's a little bit harder than that one as well. I think you guys are doing very well. You guys can just keep up with me. So now we're given the following expression and asked to solve for x. We're given 3 to the power of x plus 2. So we have a 3 to the power of x plus 2 plus 3 to the power of x plus 3 plus 3 to the power of x plus 3 minus 3 to the x. The x is equal to 315. Okay. Now, in this case, we can see that we don't have a single term on either side. On the left-hand side, we've got 3 terms, and on the right-hand side, we've got 1 term. So we can't just basically multiply them together and add our exponents. We've got to find an alternative method in this case here. So what I want to show you is an example of the reverse of what we did before, right? Is that if we're given x to the power of a plus b, that's the same thing as saying x to the power of a times x to the power of b. So we're going to do that with the numbers we've got on the left-hand side and then write them out so we can try and see if there's something that we can do with this expression. So that means here we're going to have 3 to the power of x times 3 to the power of 2 plus 3 to the power of x times 3 to the power of 3 minus 3 to the power of x is equal to 315. Something must pop out at you now, because what you can actually see is that we end up with some common factors. So there's a 3 to the x there, a 3 to the x there, and a 3 to the x there in each of the terms. So we can actually take out this 3 to the x in our expression and factor it out. So if I factor out my 3 to the x, let's see what we have left. So we've got now a 3 squared, so that's going to be 3 squared plus my 3 cubed, which is 3 cubed. And then here we took out the 3 to the x, so we just got a 1 left, minus 1, and that's equal to 315. So now we can take the numbers in the brackets and we can then simplify them out. So then 3 squared becomes 9, 3 cubed becomes 27, minus 1. So 9 plus 27 gives us 36 minus 1 is 35. So we've got 3 to the power of x times 35 is equal to 315. Now we can divide through by that number that's sitting over there to get the 3 to the x by itself. 3 to the x is equal to 315 divided by 35, and then we can grab a calculator and see what we end up there. We then have 3 to the power of x is equal to 9. You'll see if you divide 315 by 35, you end up with 9. And now there's a familiar number that we can put to a base 3. Therefore, 3 to the x is equal to 3 squared. I can now again do our favorite move and drop our bases, keep the exponents, and we note that x is equal to 2 in that expression. So those are just some exponential equations that we can work with. Join us in our next video where we do more complex examples of exponential equations. Thank you.